In today's lesson, we're going to be factoring again, but this time we're going to be factoring a special situation called the difference of two squares. There will be no b term, no middle term in these polynomials. So let's show you what I'm talking about. First of all, let's define perfect square. A perfect square is a product of the same number. For example, 4 is a perfect square because it is a product of 2 times 2. And 9 is a perfect square because it is the product of 3 times 3. So the perfect squares, starting with 1, and you should know these, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. Then there's 4 times 4, 5 times 5, 6 times 6, 7 times 7, and I do want you to list these in your notes. This is 8 times 8, 9 times 9, 10 times 10 is 100, 11 times 11, and then 12 times 12. And that's your perfect squares that go up to 12. So make sure those are in your notes. Alright, other examples of perfect squares would be variables. So here's a variable with an exponent of 2. Well, what could I multiply by itself to get x squared? And that would be x times x. So x squared is a perfect square. Now what would I multiply to get x to the fourth? Well, I could multiply x squared times x squared to get x to the fourth. So x to the fourth is a perfect square. In fact, any exponent that is even would be a perfect square. So x to the sixth would be x to the third times x to the third. So that is a perfect square. X to the eighth would be x to the fourth times x to the fourth. And the reason is because we add the exponents together. Alright, so let's look at a coefficient of 16 and then a variable of x squared. Well, what is the square root of 16? You would get 4, and the square root of x squared would be x. So 4x times 4x is 16x squared. So that means 16x squared is a perfect square. So these are all examples of perfect squares. So the first thing you want to do is to be able to identify what a perfect square is. In example number 1, I can see that I have perfect square here. X squared we just said was a perfect square, and 4 is a perfect square. And look, I have no middle term and I have a subtraction sign. So the difference of two squares works when there is no middle term. So write this down. So there's no middle term. You have perfect squares, two perfect squares, one in the beginning and one at the end. And then they are separated by a subtraction sign. So the subtraction sign will be in the middle, and that's called the difference of two squares. So the way you would factor it is always going to be the same, and I'm just going to show you how it works, and then I'm going to do FOIL to check so you can see why it works. So what you're going to do is take your first term, and you're going to take the square root of that first term. So the square root of x squared is x. So I'm going to take an x there, and I'm going to put an x there. Then I take the square root of the second term. So the square root of 4 is 2. So I put a 2 here and a 2 there. And then all I'm going to do is I'm going to add a plus sign to one of them and a minus sign to the other. And this is how you factor the difference of two squares. Now let me FOIL this to show you that it works. So first terms I multiply to get x squared. Then I do the outer terms. I would get negative 2x. The inner terms would be plus 2x, and the last two terms would be minus 4. Well, notice when you combine like terms, the middle terms cancel out, so you would get x squared minus 4, which is what we started with. Pretty simple. So example 2, again, you have to have no middle term, you have to have two perfect squares, and there has to be a subtraction sign. So on this one, we see that we have m squared, that's a perfect square, and 81 is a perfect square. So the way I would factor it is I would set my two binomials, get my two binomial parentheses ready, take the square root of the first term, which is m, and put it in front. Take the square root of the second term, which is 9. 9 times 9 is 81. And then you can put a plus sign here and a minus sign there. It doesn't matter which one goes where. And then I can FOIL to check. So I would do m times m, that's m squared. Then m times plus 9 would be plus 9m. And then minus 9m. And then 9 times 9 is 81, and it's a minus sign. Again, the two terms in the middle are going to cancel out. So I would get m squared minus 81. So your answer, when I ask you to factor, this is your answer right here. This is just where we check. All right, let's do some more examples. Okay, so example 3. First we want to see, do we have a perfect square? And you also want to see, is there a GCF? Because if there's a GCF, a greatest common factor, you should factor that out in the beginning. So I'm going to look and see, is this a perfect square? Yes. Is this a perfect square? Yes. Is there a GCF? No GCF. So I'm going to set my parentheses up, and then I'm going to take the square root of 4x squared. So I would get 2x, because 2x times 2x is 4x squared. So I put the 2x there and the 2x there. Then I take the square root of 25y squared, which would be 5y. And then I put it on both sets of parentheses. Then what do I put in the middle? I put a plus and I put a minus sign. And there is my answer. And you can always FOIL to check. All right, example 4. First you want to look, do you have perfect squares? So 2 is not a perfect square and 98 is not a perfect square. But I do see that they have a greatest common factor that I can factor out, and the greatest common factor is 2. So I'm going to factor out a 2 from both terms. First I do that. So when I factor that out, remember whatever the GCF is becomes part of your answer. So then I would be left with t squared minus, and 98 minus divided by 2 is 49. Now look, I have the difference of two squares because I have a perfect square here, a perfect square here, and a minus sign in the middle, and that's what I'm looking for. So now I'm going to continue factoring. So I always bring down the greatest common factor. That becomes part of my answer. Then I'm going to set up the two sets of parentheses. I take the square root of t squared, which is t, put that on both sets, and then I take the square root of 49, which is 7. Then all I do is add my plus sign and my minus sign, and this would be my answer. Now you can double check this by multiplying. Okay, so first I would probably FOIL. So I'm going to leave the 2 here, and then I'm going to FOIL the center. So I do t times t, that's t squared. Then I would do t times a negative 7, which is negative 7t. Then 7 times t times a positive 7. And then I would get 7 times 7, which is 49, a minus sign. This cancels out in the middle, so I end up with 2, and then I have t squared minus 49. Now if I distribute the 2, so distribute the 2 by multiplying back in, I would get 2t squared minus 98. And that's what I originally had in the beginning. So I know that this answer that I got right here is correct. All right, let's go do a couple more, and then I'm going to show you a couple of tricky ones that that might trick you up. All right, in example 5, again, you're just looking for the difference of two squares. So 9x squared minus 4, is that a difference of two squares? And yes, because you can break that down into 3x times 3x. And then you can break this down into 2 times 2. So then I do a plus sign and a minus sign. And notice I didn't have a greatest common factor. You always want to double check, do I have a GCF before you do this? So let's look at the next one. And let's see, do I have a GCF? Well, yes, I do. Greatest common factor. So what is the greatest common factor of 4 and 144? You could try 2, because you know that 2 goes evenly into both. But I know that the greatest common factor of this is 4. So I actually have to divide out of 4 first. So I divide out of 4, and what am I left with? These cancel, so I get t squared. And then 144 divided by 4 is 36. So now I still have the difference of 2 squares. So here I have t squared. So I'm going to write this, the difference of 2 squares, with 2 sets of binomials. T times t goes in the front of each. And then the square root of 36 is 6. So I'd put a 6 there, a 6 there. And remember, this is a minus sign, so that means I'd have a plus and a minus sign right here. If you don't factor out the GCF first, let me show you how this works. So if you just started out with 4t squared minus 144, and you saw that that was a difference of 2 squares, which it is. So what you could do is just go ahead and factor the difference of 2 squares, and we will take the greatest common factor out last. So I would put a 2t here, because 2t times 2t makes 4t squared. And then the square root of 144 is 12. So I'd put a 12 here and a 12 there with a plus and a minus sign. But notice now that both of these can be factored by a 2. So I need to factor out a 2 on this one, and then I need to factor out a 2 on this one. And when I factor them out, whatever I factor goes in front. So I'm factoring out 2 2's, not just 1. I'm factoring out 2. So I have 2 times 2, so that goes in front. And then I'm left with t plus 6 and then t minus 6. So then 2 times 2 is equal to 4. So I know that I end up getting the same answer that I started with. So when you factor out, whatever you factor out goes in front, and you have to multiply. All right, let's show you 2 kind of tricky ones. All right, example 7, you have x squared plus 36. This is an example of a prime polynomial that you cannot factor because it has a middle term with no middle term, but it has a plus sign. So yes, this is a perfect square, that's a perfect square, but you don't have a minus sign. So this would be what we call prime. There are no 2 factors that can multiply to get that binomial. Number 8, you notice right away, or hopefully you do, that 100 is a perfect square, x squared is a perfect square, but 10 is not. However, they have a GCF, and the GCF is 10. So you really should factor out a 10 and see what you get. So take the 10 and put it in front. Whatever you factor goes in front, and then see what you're left with. 100 divided by 10 is 10x squared minus 1. Now, you should notice and take a look at this. Do you now have a perfect square? So this x is a perfect square, this is a perfect square, but 10 is not. 1 is a perfect square, and then you do have a minus sign. But since this is not a perfect square, then there's nothing else you can do, and you are done with this particular problem because it will not factor anymore. So those are some examples of some tricky ones that you might see from time to time. And we're done. So thanks for watching, and get ready to do your homework.